Okay, guys. So, last lesson, we were dealing with y is equal to mx plus b. Can you guys find that on your formula sheet right now? Yes. So, guys, if you found this one right, what was the name of that one? That one was slope.
Intercept form.
So that was slope intercept, right? So it's kind of all in the name. So when we were graphing those, this one was useful when you had the y-intercept and the slope, right? This is the slope, that's the y-intercept. That's why it's called slope-intercept form, right? Now what we're going to be doing is something called point-slope form or point-slope equation. So this one actually just has a point and a slope in it. So if you've got, so it's written like this on your formula sheet. So if you can see this one, it's y minus y1 is equal to m times x minus x1.
Wait, is that other x like x2?
Yeah, this one is on your formula sheet there too. It's called slope point form.
Now, what's the first?
Okay, so looking at this might look a little bit familiar to you guys. What if I took this x minus x1 and just divided it on both sides, right? So I just like moved it down here. Let's see if this starts looking a little bit more familiar. So this would be y minus y1 over x minus x1 is equal to m. Have you guys seen that before?
Yeah.
Or something similar? What is that? This is really just our slope formula, isn't it? That we're using, just the change. Like that's all this is. This is just like rearranging this thing.
So that unmarked y is y2 basically.
So what this is, so remember when we had like y is equal to mx plus b, that's how we have to have an equation is like a y and an x, right? Now, the y1 and x1, these are going to be numbers. We're actually going to put numbers into that when we're done here, and then we'll have a y and an x in our equation. So that's pretty much it. So this will be a point. This would be like the y value in our point, and that would be the x value in our point. And then we also have the slope. So this one's it's the same thing. Like this is still just an equation for the line, but this is just useful because now if I have a point and I have the slope, I can just like throw it into my equation, right? It's actually just handy that way. I don't need my y-intercept or anything. Does that make sense? So, well, I'll show some examples. I think that'll make sense. So that's everything I just kind of showed there about rearranging that. And then, okay. So examples there, but we'll kind of skip through some of these and we'll do some examples below. Yeah, same thing. All right, so let's do this one. It says, write an equation in standard form for the line. Okay, so we haven't really talked much about standard form. So again, on your formula sheet, can you guys find standard form?
Yeah, it's ax plus by equals c.
Right, so you've got ax plus by is equal to c. So the a, the b, and the c are just numbers. Right, so I'll show you what I mean. Like in the end here, it'll make sense. So first off, what we always want to do is just put it into like any form we can. So we want to look at the line and figure out, okay, what do I know and what can I do here? So they've given us a point, and we can tell the slope from the graph. So we're going to just put it into point slope form. And then from there, we're going to do a little bit of algebra and change it into this form, just standard form. Okay? So step number one, let's put this thing into point slope form. We could actually put it into slope intercept form too, because we know the y-intercept. But on this lesson, we're doing point slope, so we'll do that one. So let's write down our equation. It's y is equal, or no, sorry. It's y minus y1 is equal to m times x minus x1. So this is our point slope form. All right. So there's our point. And there is a x1, and there's a y1. You guys have any ideas how we're going to start piecing this thing together? Put those into the right spots, right? So if that's an x1 and that's a y1, let's put them into the formula in the right place. So this would be y, and then careful on this though, because it's still y minus -3. So that's going to become y plus 3 in a minute, right? So that's equal to, I don't know m yet, so we'll just leave that for a second. And then x, and then our x, one value is 4, so that's going to be minus 4. Okay, I'm going to rewrite that as just y plus 3. So y plus 3 is equal to, here, and I'll just write it all again, m times x minus 4. Okay, so we're almost there. We just need to figure out now what the slope is, right? So how can we figure out what the slope is? Rise over m, right? So let's find places where it crosses nicely. So maybe there, and I think right there. So what does this thing do? It goes down 2 over 1, right? So over 1. So we have a slope. So from that, m is equal to negative 2 over 1, or just negative 2. Okay, so good to go. Y plus 3 is equal to, and then what am I putting in for m? Negative 2, right? The slope we just found. So negative 2, and then x minus 4. Okay, so that's it. That actually is just the equation of our line, right? So that is in point slope form. I shouldn't don't get too excited yet. So that is the equation. Now, what we have to do is just arrange it in different ways, right? So there, you guys have seen slope intercept. We've seen point slope, and now there's standard form, right? So they just want us to put it into standard form. So this was our standard form. Right. Do you guys kind of see the general thing we want to get? We want to get the x and the y to the same side, and then the whatever, just the constant, so no variable attached to it, on the other side. So right now this is still a little bit of a mess. It doesn't look like that yet, right? Does anyone see what the problem is? Maybe over here that I got to deal with first.
You gotta get
The x minus 4. Yeah. Well, I could bring it to the other side, but you see how I'm multiplying there? I'd have to like divide it, right? And that's not really going to help me. I don't want anything in the denominator. I just don't like those brackets, right? How do I get rid of brackets? Yeah, rainbow. Yeah, we got to distribute that in, right? So let's do that. So write it again. We got y plus 3 is equal to negative 2x, and then negative 2 times negative 4 is, yeah, positive 8. Yeah, I even do that sometimes. Okay, so that looks better, right? You guys kind of see now that we're a little closer to this form. We've got, there's my x term, there's my y term. I've got 2 constants right now, though. So, any ideas what we should do here? Yeah, collect like terms, right? So we'll collect like terms where we can. And according to this, that 3, I'll move it over here with the 8. Right? So let's get it to the right side of the equation there. So do you guys remember if I move my positive 3 from this side of the equation, what is it when it goes to the other side? It's negative, right? Because you're subtracting from both sides. So we're really going to subtract 3 from both sides. But in the end, it's y is equal to negative 2x. And then this is going to be minus 3 when it comes over here. So 2x, so 8 minus 3 is 5. So plus 5. All right, so now this looks really close. And actually, before we go any farther, what kind of form is that in right now? Yeah, that's mx plus b, right? That's our slope intercept form. So if it asked for that, then that would have been the answer, right? But they asked for standard form. So one last move, what should we do? Yeah, I think this x term, right? So it's negative right now. It's negative on that side. So when I bring it over to the other side, it's going to be positive, right? So this will be, so just 2x plus y is equal to 5. And then that's it. That's our equation of our line in standard form. Okay, good. Okay, one little caveat here. We could have, like at this point, right? We could have moved, let's say, like on this one, right? We could have moved the y over there and the 5 over there. Like we could have moved them to whatever side we wanted, and that still would have been fine. The only issue is, technically in standard form, this should be positive, right? This should be positive x out front. So you just always want to keep like that x value positive. Technically, like it's fine. Like I don't know, it can be written the other way sometimes. But if you want to be really in standard form, the x value should be positive, and it should be the x value first and then the y value. So just like it looks on your formula sheet. Okay. All right. Moving on. So someone says, describe the graph of the linear function with this equation. Okay, so when it says describe, just like we got to pull out what kind of information we know from this thing. First off, what type of form is this in? You can use your formula sheet if you want to cheat there.
Right now it looks like slope line.
Yeah, this is in slope point form, right? So what do we probably know about this line? We know the slope and we know a point. Yeah, that's it. So that's what we know. So let's just figure this one out. So the slope of this guy, let's write it down, would be what? Yeah, -1/2. Okay, and then a point. So I'll just call that like maybe point P, and then put it in brackets. Now this one might be a little bit harder to pull out, but I'll show you what the trick will be here. So if it's y, the equation is y minus y1 is equal to m x minus x1. Okay, so if I want to figure out what the point is here, it's always going to be the opposite of the signs, right? So in this case, if this is -2, then the point would actually be at 2 for my x value. And if it was at +1, it's actually going to be -1. And let's just to make this make sense, I'll show you why, right? So if we were putting this back into this equation, right, this point, do you see that if it was, so y minus, and then if I put -1 back into this, right, that'd be -1 like that. Do you see how that would really be y plus 1? Which is exactly what the question was, y plus 1. So that it's because the equation is actually minus there, that the point would actually be the opposite sign when it actually goes in. Does that make sense? Okay. Well, we'll work on it after.
I'm very confused right now.
Well, okay, let's do it one more time. So I'm telling you that this is the point in our equation, right? Or like actually on our graph. So if this is my y value, right, and I actually put it into my equation right there for my y1, then if that goes in, that's going to be y minus, and then when the point goes in, -1, that's going to be -1 going in like that. And then minus and negative, that's y plus 1, right? So that's why the equation is y plus 1, like, or the way it looks, right? It gets a little tricky because it's all because the equation itself has a negative in there. So when they throw negative numbers in for y1, the signs end up being different. Okay? Yeah, that could be a little confusing, right? So just be careful on that one. When you're looking at the points, or like looking at the equation, you can just remember it too, that the points will always be the opposite of the signs. When they with like the actual points there, yeah. Okay, so that's what we know. We know the slope of that, we know that point. So it says write the equation in standard form. Okay, so to do that, it's going to be y plus 1 is equal to -1/2 x minus 2. So we already have like the equation written this time, but it wants it in standard form. What do I got to do here? Yeah, we can distribute this, right? So let's get rid of those brackets. Okay, so we'll write it all again. So y plus 1 is equal to, and then -1/2 times x is just -1/2 x. That's all we can do. -1/2 times -2. Yeah, just 1, right? And if you guys are having trouble with that, just all that was -1/2 times 2, which is really like 2 over 1, right? So then it's like 1 times 2 is 2, 2 times 1 is 2, 2 over 2 is 1. Oh, sorry, and that was -2. So negative times negative is a positive as well. So positive 1. Okay. Now what? Yeah, we can subtract the 1 from that side and the 1 from that side, so they cancel, don't they? So then we've got y is equal to negative 1/2 x. Okay, so then that x, if we're in standard form, remember how this is. This is ax plus by is equal to c. Yeah, so it's going to be 0 if you want. We can always call that plus 0 if you like. Or just leave it there.
But then wouldn't that be general form?
No, we're still moving it.
Or no, it would be equal 0.
Yeah, actually, I know what you mean. But okay, so let's bring this one over here. So this will be 1/2 x, right? It's positive now, plus y is equal to 0.
So
Now that pretty much is, but the only thing that's not technically right,
it's just the
because if it's truly in standard form too, we don't like fractions. Well, we don't like decimals either. But we have a little trick here. We can get rid of our fractions, right? If I don't like that 2 in the denominator, you know how I can get that out of there? We can just multiply every term by 2. Do you guys see that little...
So wait, what, if there's a 3, you just multiply everyone by 3?
Yep, if there was a 3 in the bottom, you multiply everyone by 3. We just do whatever we have to do to cancel the bottom, right? So do you see now we have 2 over 2, those cancel? So the 2's cancel. So we end up with just 1x, or x, plus 2y is equal to, and then 2 times 0 is just 0. So now when you said, isn't that in general form? Yeah, the c in this case was funny because it canceled, but it's just 0. Yeah. Yeah, so that's it. Now, I think it's worth going through this because we could have taken a little shortcut on this part too. It makes life a little easier if you understand what's going on. So I'm going to show you guys that shortcut too. So when we had y plus 1 is equal to negative 1/2 x minus 2, I could have just right off the bat said, you know what, I don't like that fraction down in the bottom. And what I could have done is I could have multiplied each of these by 2. So multiply this by 2, and then each term on that side by 2. And then that would have got rid of that fraction right off the bat. And sometimes that can make life easier because when we had to distribute the fraction in, and sometimes it's a little harder with fractions to distribute them in. So those would cancel, and we'd end up with 2y plus 2 is equal to negative 1 if you like, x minus 2. And then that negative would have distributed in there. So we've got 2y plus 2 is equal to negative x plus 2. You guys see again that the 2's would cancel. And we'd end up with x plus 2y is equal to 0. So you get the same answer there. So if you understand what I did there in this one here, where I just got rid of that fraction right off the bat, that I find that easier. Then we never had to deal with the fraction all the way through. Okay, so that's an option. Okay, you know what? For the sake of time, let's we'll move on. I think we'll go to the next one. Okay, let's skip through this one too, just so we can get through everything. Okay, so same type of thing, but if they give you the x-intercept and the y-intercept, then really those are 2 points, and we just kind of do the same little idea there. So let's do number 4. So it says write an equation in standard form for a line with an x-intercept of 4 and a y-intercept of negative 2. Okay, so really quickly, it might help to kind of sketch that. So an x-intercept of 4, so that would be at the point 4, 0. And a y-intercept of negative 2, so that would be 0, negative 2. So it helps to write those down because now we want the equation of the line that goes through those. Okay, well, we have 2 points, so we can use our point slope form here. Okay, so let's figure out, well, let's write down our equation first. So y minus y1 is equal to m times x minus x1. Yep. So there's our equation. Really, we just want to throw things in, right? We want to plug in what we know. So we're going to need the slope. So let's figure out the slope. So m is equal to, how can we use these points to figure out the slope? Yeah, well, you could do that. You could draw like a little triangle, rise over run. That's fine if you like doing it that way. I'm just going to use the standard y2 minus y1 over x2 minus x1. Okay, so then our slope would be, okay, so I'm going to call this my, that'll be x1, y1, x2, y2. So my y2 is 0, my y, and then minus negative 2 over, and then my x2 is 4 minus 0. So my slope is going to be 0 plus 2, right? So 2 over 4. So my slope is going to be 1 over 2. Okay, so I'm going to need that.
So it's basically almost like the other question again.
It is, yeah. They're all kind of similar, yeah. Okay, so then we're pretty good to just kind of throw things in here. So this y and this x stay, right? We're not going to replace those with anything. We're just going to replace the x or the y1 and the x1 with 1 point. So it's going to be y well, I'm not sure minus yet. My y1, what am I going to use for my y1? Yeah, I can actually use either point. It doesn't matter what point. Any point on this line will work. So we have 2 to choose from. It doesn't matter which one. So yeah, we'll use the negative 2. So it'll be y minus negative 2.
Could we put it as y plus 2?
Yeah, if you understand what you're doing there and you call it y plus 2, that's good. I'm just kind of doing right with the equation. So okay, so it's that, and then our slope. What's our slope?
1/2.
Yeah, 1/2, right? We found that. And then x, and then what's our, this will be x minus, well, remember we're doing this point.
So it's the x minus 0.
Yeah, right? That was our y value was negative 2. We have to use the same point. Yeah, we have to stick with that one. Yeah, so, yeah. Okay, so let's simplify that up a bit. Let's call that y plus 2 is equal to, and then this is just 1/2. X minus 0 is just x, so 1/2 x.
What form did it run in? Actually?
It wanted it in standard again, yeah. So that's so standard, so it wants it as ax plus by is equal to c. Okay, so we're close. Let's just get the x term over to the left side. Actually, no, you know what? I'm wrong.
Can't you just bring the y?
Let's bring the y over. You're right, because we want the x to be positive. So we'll leave the x there. I'm going to bring the y over to the right. So we're going to subtract y from both sides. So minus y. So we've got 2 is equal to 1/2 x minus y. Now I know this is written the other way. That's fine, because c is equal to ax plus by. That's fine. That's the same thing, right?
Didn't it want us to get rid of the half?
Yeah, we don't like the half though, do we? How do I get rid of that half?
You just put 2
Times
on.
2 by everything.
Right, we're going to multiply every term by 2. Right, so then that 2 over 2 cancel. So we end up with, well, 2 times 2 on that side is 4 is equal to x minus 2y. And there we go.
No, because now.
Yeah, and that's fine, right? Yeah, it's fine that it's written like that instead of the other one. That's still standard form. Question. So the question was, this one says the equation was plus by, and this one's like minus by. Is that what you're saying? It actually is still the same, because this could be written as 4 is equal to x plus negative 2y. Whenever we write a negative, we really mean plus, or whenever we write a minus, we really mean plus a negative. So they really are the same thing.